Now let's practice more with the algebraic properties, specifically so we can use them in solving equations. So let's just practice simplifying these first two examples by combining the like terms using the algebraic properties. So I know that in order to use, for instance, the commutative property, I want to change all my minus pieces to plus negatives. So I'm adding the additive inverse. So now it's all addition, so I can use the commutative property to switch them around. So I probably want to get my y's together and my x's together. I think that should be my goal. So if I switch these two, my 4y and my negative 2x, that will happen. Now I have 3x plus negative 2x plus 4y plus negative 4y. Now notice here, I can use the associative property and work on this piece first. So I have 4y and I'm then adding negative 4y. Well, that's adding a number and its inverse, its additive inverse, so that's just 0. Then I can deal with these two. I have 3 x's and then I'm adding a negative 2 x's. So I have 3, I'm taking away 2. So I end up with just x. So this whole expression using the commutative and associative properties ends up just being x. Now let's look at this one. Again, I want to switch all my subtraction to adding the inverse. Then I know that I'm free to use the commutative property whenever I want. And again, I probably want to group together my x's, my y's, and in this case my z's. So I think if I switch these two pieces, that'll happen. So I get 2x plus 5x plus negative 3y plus negative 4y plus 7z. So I can add together my x's using the associative property, or I could start with my y's, and z is by itself, so I don't need to start there. Just for the fun of it, let's start with our y's. So I have negative 3y plus negative 4y, so that should be negative 7y. And then I can use the associative property to add my x's. So I have 2x plus 5x, well that'll give me 7x. And notice that I actually have 7's as my coefficients for all of my terms. So this is perfectly fine as a simplified version of this. However, I could also factor a 7 out, or pull a 7 out, and write it as 7 times x minus y plus z. This way, all it really changes is that I've kind of reverse distributed a 7. Either one of those would be okay. Okay, so now that we know how to use the algebraic properties with variables, let's get some practice solving some two-step or one-step equations. So this first equation is a one-step equation. I want x by itself. That's my goal. I want x equals some number. So I need to get rid of this minus 2. So I want to do the opposite. I want to add 2 to both sides. So I have x minus 2 plus 2 is equal to 0 plus 2. But the minus 2 and the plus 2, just like we saw over there, we're adding a number and its additive inverse. It is going to be 0. So x is just equal to 2. We can do the same thing here. I have x minus 3, so I want to add 3 to both sides. I get x minus 3 plus 3, so that'll just be x. And I have 0 plus 3, so that's equal to 3. Now let's look at this example. We have x plus 7 plus x equals 3. So, first of all, before I can do anything else, I need to collect my x's together. So the commutative property tells me that I can switch around my 7 and my x, so I get x plus 7 is equal to 3. Then I can combine these two to get 2x plus 7 is equal to 3. Then I need to subtract a 7 from both sides, because I need to deal with this before I start dealing with this 2 that's with the x. So I subtract 7 from both sides, so it's going to become just 2x on this side. Then I have 3 minus 7, so that would give me negative 4. Then I just need to divide by 2 on both sides. So this will give me 2x over 2, or just x, and then negative 4, no x, over 2. Well, this simplifies to be negative 2. So we get that x is equal to negative 2. We can double check that this is correct. If I put in negative 2 plus 7 plus negative 2, that should be equal to 3. So negative 2 plus 7 would give me 5, plus another negative 2 would give me 3. It is indeed equal to 3. So anytime I'm dealing with an equation I want to solve like these, I can always put my x back in and double check that I did it correctly. Now let's look at this last one. Notice that I have x's on both sides of my equation. So I need to get those together onto one side before I can do anything else. So I think that I want to subtract 4x from this side. So, using the commutative property, if I write this as plus negative 4x, I can switch these two, and I'll see that I have 4x plus negative 4x. Those will just be 0. That's why I chose to subtract 4x. Now I have 5 plus 7 minus 4x, that's 3x. I still have this 5 here, so I need to move the 5 to the other side. So if I subtract 5 from this side, it'll make the 5 go away. If I subtract 5 from this side, I get negative 4 is equal to 3x. So again, I need to divide both sides by 3, so I'll get x is equal to negative 4 divided by 3. We can double check this. So let's take 4 times negative 4 thirds plus 1. And we want to know if that's equal to 5 plus 7 times negative 4 over 3. Well, 4 times 4 would give me 16, so I have negative 16 thirds. I'm going to write the 1 as 3 over 3. And I want to know, is that equal to 5, which we're going to be working with everything over 3. So I'm going to write 5 as 15 over 3. All I did was multiply 5 by 3 over 3, which is 1. And then 7 times negative 4 is negative 28 over 3. So when I add these, I have the common denominator, so I can just make them into one fraction. So negative 16 plus 3 is negative 13 over 3. Here I have 15 plus negative 28. They're both over 3. So I can make these into one fraction. So 15 plus negative 28 would also give me negative 13 over 3. So we're no longer questioning. We know we did this correctly.